All right, I'm Steve Hicks here to talk about FlexRadio for the next hour. I have about 74 slides for an hour, so we'll see if I can actually get through those, and then I have questions after that. So I've been a ham since 78. The part of the hobby that I like most is microwave roving, so this is a picture of my microwave roving rig, and just to show you guys kind of what my main interest in the hobby is. So FlexRadio was started in 2003 in Austin, Texas. We are a software-defined radio company, and we have around 30,000 radios worldwide that are installed. So talk a little bit about SDR and why would you want a FlexRadio. For those of you that are already customers, you already know the answers to these, but maybe you'll learn something anyway. I want to talk about the new Flex 8000 series that we introduced in May of this year. Talk a little about the new Maestro, our PGXL, TGXL integration, which is our high-power amplifier and tuner, and then talk about our software roadmap and take any questions. Okay, so what is an SDR and why would you want one? So this is kind of a block diagram for a typical radio. You have an antenna that goes into a mixer. You take that frequency off the air, you mix it down, you put it through a filter. There's an amplifier, demodulator, audio amplifier, and you send it out a speaker. And you got a local oscillator there with a knob you can turn. And all these boxes that are red here are analog components. So it's a very basic block diagram. So what are the drawbacks to having an analog radio? Well, demodulation and modulation require separate circuits for every mode of operation that you're going to encounter. New modulations can't be added after the fact because they're in circuitry and you just can't add circuitry easy after the fact. The bandwidth of a radio like this is typically restricted on an output style, and also if you have multiple heterodyne stages or multiple mixers in the radio, each one of those adds distortion to the radio. So there's a lot of commentary from various radio manufacturers on this, but this is a well-known problem. So one of the things we can do is after we have our filtering section, we can put an ADC there, an analog to digital converter, and do our demodulation, filtering, and then go back to the analog world with a digital to analog converter in the digital domain. So these blue boxes are pieces of digital electronics that we've added here. And some people would call this an SDR. I probably wouldn't because most of the front end of the radio is all still analog electronics. So what does this radio buy you? Well, now that all the demodulation is done in software, you can add new software modes after the fact with updates. You have the ability to do more dynamic filtering because your filters can be defined in digital signal processing, and you can change them and add new kinds of filtering, that kind of thing. The other thing you could do is you could have multiple receivers inside of that narrow bandwidth. So some of the manufacturers did this. I know iComet did at one point and called it, I don't know, they had a name for their second receiver that was inside that bandwidth. So if you look at this picture, is there anything more we could do here to make this radio better? What about all this stuff up front? Is there a way to change that out? So you can, and this is called a direct sampling software-defined radio. So what is direct sampling? In a direct sampling radio, we take the analog to digital converter and we put it essentially right on the antenna. Now you might have some band-based filtering or something in front of that, but essentially you suck in all of the RF that the antenna can provide you, and then you do all of your mixing down to an IF frequency, your filtering, even your local oscillator becomes what's called an NCO or a numerically controlled oscillator, all done inside digital signal processing circuits. So this radio is really an SDR because everything in here is software. So if you didn't like the number of receivers you had in it or wanted to change out any of the guts, it's all software and you can update it. So what are the benefits of this? Well, you get minimal distortion because you put the analog to digital converter right on the antenna and you convert from the analog domain into the digital domain. And then if you handle all your math and DSP correctly, you won't introduce any additional distortion in the digital domain. So you get rid of all the distortion that happened in all the mixers. The other really cool thing about this is that once you have the data from that antenna, you can take that and copy it and use it multiple times and make as many receivers as you want in that radio, which is a really cool thing. If you look at what happened in the analog world, even 10 years ago, you go buy a radio, and if you bought one that had one receiver, it was N dollars, and if you bought one with two, it was N times 2 or something, because you had to have all that second set of analog electronics to do that. In a radio like this, you can add an additional receiver with just more compute power, so it becomes a lot less expensive. You can also add a fast Fourier transform to convert the voltage level time domain signal that you receive off the antenna. You can convert that into a spectrum display. So all of the SDRs today have spectrum displays on them, and they're created with this. And you can, again, with the right processing power, you can add as many of those as you want. You have very high dynamic range with today's analog to digital converters, and if you look at the top of the heap, like in Sherwood's chart, you'll find that all of those radios are direct sampling because they have more dynamic range in them. Dynamic range essentially is the difference between the strongest signal and the weakest signal you can hear at the same time. And you want a lot of that so that if there's a really strong signal next to the guy that you're trying to work who's just out of the noise, you can actually hear him. You do get a lot of programmability capability here where you can just continually update the software, and this is one of the things our customers really appreciate about us is we always update the software. They are more challenging to design, and it is a completely different engineering team from your analog team. So if you used to be an analog radio design team and you wanted to go start doing this, it's a completely new set of engineers to design most of it. So that is a thing that keeps some people from doing it. So going back to our picture here, I mentioned, you can go add multiple receivers. Well, you do that just by going and doing something like this. So you take the data out of the analog to digital converter, and you go convert. You just go make another copy of it in your electronics, and go make a second receiver out of that. So it's a very, very nice thing to do. So this is the high-level architecture of both the Flex 6000 and 8000 series. 6000 is our radios that we've been selling for about 10 years. The 8000 is the new radios that we've announced back in May and are just now shipping. So we have, you can see there's these dotted lines here around these things called SCUs. This is what we call a signal capture unit, and it has a combination of filters on the front end, pre-selectors, preamp, attenuation, and an analog to digital converter. That block you have to have in the analog world, but once you convert that signal into digital, it goes into an FPGA and a baseband, and you can build multiple receivers after that. I'm not going to spend a lot of time talking about the rest of this diagram, but if y'all want to ask questions about it later, we can do that. So you can get a brilliant display like this out of a radio like this that lets you see significant portions of the band. You can zoom in. You can have, in this case, I have multiple pan adapters and waterfall displays that are shown at once. Our high-end radios allow 4 to 8 of those, so a lot of things you can get out of it. So now that, when we introduced the direct sampling radio architecture in 2011, a lot of the other radios on the market said they're not going to be as good. You don't want one of those. It quickly proved out to not be true, that they are, direct sampling radios are the best thing you can have. And so most manufacturers now have converted to direct sampling radios. So knowing that you have a lot of choices on for buying a direct sampling radio, why would you buy FlexRadio? Well, here's a few reasons. Flex has the best remote capability on the market. When we designed the radio architecture in 2011, we designed it from the ground up to be remotable. Everything's done over Ethernet, so that's a key capability in our radio. We have an application programming interface that allows anybody to come in and write applications that run against the radio, create new waveforms, all kinds of things like that. And as a result, there's a number of applications that run against the radio that add new features and that kind of stuff. We do have a cloud-based broker that if you're using our radios for remote, it gets around the NAT problem where you can't get back into your house or something. The radio actually logs into a remote server. When you leave with your computer, or this is a Maestro, which I'll talk about in a minute, you can connect to our broker. It'll tell your Maestro or your computer where your house is, where your radio is, and allow you to connect to that. So it facilitates the connection, but otherwise doesn't do anything. I mentioned earlier that you can get multiple receivers, and this is one of the key capabilities that we offer. One of the things you could do, like with a Flex 8600, is you can listen to 4 bands at once, run 4 copies of WSJT or JTDX, and do 4 FT8 bands at the same time. So you could be listening to 10, 15, 20, and 40 all at the same time, monitoring those. And when you see somebody you want to work, you just click on that instance of WSJT. The transmitter automatically switches to that band, and you work that contact. So that's a very unique thing that FlexRadio can do that no one else on the market today can do. because of the way the architecture is geared and we have all of HF in the radio, each one of the receivers that we give you can be placed anywhere. So some other radios have restrictions on the receiver has to be placed within 36 kilohertz of another one or something like that, and we don't have any restrictions like that. We also have a unique capability called digital audio exchange, which allows you to take streams of digital data out of the radio, pipe them over to Windows or Mac, and then use them for digital modes like FT8. And so you get a control panel that looks like this, where you can control each of those streams, run them to different IP addresses, whatever you want to do, and it gives you a lot of flexibility around doing digital modes with this radio. This is a very unique capability. All of the digital modes are shipped over the Ethernet cable, so you don't need extra interfaces or cables or anything like that. All the data goes across the Ethernet into your computer and then shows up as a sound card. As I mentioned, everything in the radio is controllable over Ethernet, so all the DAX commands, if you want to use CAT, we have a CAT application that runs on Windows and presents a virtual serial port. Again, all that stuff runs over the Ethernet cable, so you don't need any other interfaces or anything to do digital audio or anything that uses CAT. You can run the DAX and CAT applications on multiple computers. So if you wanted, one computer for decoding digital data and another one for recording audio or something, you could do that. Again, because the architecture was defined this way, we knew that bandwidth can be an issue over certain communication mechanisms, and so we optimized the data out of the radio based on what kind of data it is and how you set the settings up. So if you have a good internet connection and you want to look at your spectrum display at a high refresh rate, say 30 frames a second, you can do that. It takes about 2 megabits a second of data to do it. But if you want, you can slow that all the way down to 1 frame a second, and it'll only take 70 kilobits a second worth of data. So if you're on if you want to make a contact and you're on a cellular connection in the middle of nowhere and you don't have very good data, you can run the sliders down on all this stuff, reduce your bandwidth, and make the contact. So it gives you a tremendous amount of flexibility with what you can do from an internet bandwidth standpoint. Our radios are also SO2R and full duplex capable, so you can transmit and receive at the same time. Certain applications that allows you certain benefits, so if that's something that's of interest to you, certainly talk to us about that. And we have industry-leading phase noise, which helps a lot in contest situations as well as field day and things like that. So I won't spend a lot of time on that, but I'm happy to answer any questions about it. I think the biggest benefit for buying from FlexRadio is that we offer continuous improvement, so our software is continually updated. We just issued a release last week, version 3.8, and it's probably, I don't know, the 50th software release we've had on the 6000 series. So we're always regularly updating the software and adding new capabilities to it. In fact, I want to talk about that for just a minute and kind of do a walk down the park and show you some of the things that we've done. When we first introduced the Flex 6000 in 2011, 2012, that was about a dozen years ago, we didn't have a lot of these capabilities, and here's some of the ones that we added. In 2014, we added DAX and DAX IQ, as well as a waterfall capability, synchronous AM, tracking notch filter, quick report, record and playback, FM mode we didn't originally had, remote on the LAN. So all these things were added that year. The next year we added the WAN remote capability, we added the Maestro, we released our API, we started a developer program. So I won't bore you and go through all these things, but this is just to show you that over time we continually update the radio and add new capabilities, and that's part of what you get if you buy a FlexRadio. Okay, so I want to talk now about the new Flex 8000 series. So some people in the room will have 6000s and won't understand the difference, but I also want to talk to the folks that don't have a radio yet. So this shows you kind of what the high-level capabilities of the radio are. So there's 4 models in the lineup. There's an 84, 84M, an 86, and an 86M. The 84, with or without the M, share the same capabilities, and the 86 the same way. So in the 84, you get 2 receivers and 2 pan adapters, but you can see that under SCU, it's a 1, so you can listen to 1 antenna at a time. So you get 2 receivers, and you can put them on 1 antenna. So what does that mean? Let's say you have a TH7 tri-band beam or something like that. You could listen to 20 meters and 10 meters at the same time on this radio on the same antenna, and then you can move your transmitter between either one of those bands and transmit whenever you want to transmit. So you could monitor both those bands on FT8 or sideband or CW or whatever you want to do. On the 8600, there's 4 receivers, and you have 2 SCUs, so you can use 2 antennas at once. So let's say you had a wire antenna that was good on 40 and 80, and you had a tri-band beam. You could put each of those on one of the antenna ports, and you could put 3 receivers on one and 1 on the other, or vice versa, or whatever. So that gives you kind of a high-level view of it. Only the 8600 is capable of doing SO2R, and you can see where we have the O's here that these are options. So the antenna tuner is an option on the 8400. It's standard on the 86. We have an integrated GNSS receiver on all these radios, but there's a GPS discipline oscillator that's an option. I'll spend a very brief amount of time talking about that, and if you want to answer additional questions, we can talk about it. So if you currently own a 6000, you want to know what the differences are. This will kind of highlight some of the differences. So the case and the overall structure of the radio looks very similar. So if you switch those out, they look very much the same. We did enhance the CPU performance in the radio by a factor of about 4 and the FPGA by a factor of about 2. Excuse me. So right off the bat, that doesn't buy you anything, but the reason that we did this is that in the 6000, as we added all these features over the last dozen years, we've gotten to the limits on what we can add to the processor in the radio. So by doing this, it allows us to add new capabilities to the radio moving forward, and those capabilities are things that we'll add on the 8000, but we won't have available on the 6000 just because it won't be able to do them. So, and I'll cover what some of those are in a minute. The M-series radios have enhanced performance in the display. We also added the GNSS receiver, as I mentioned. The main purpose of this is to allow you to always be on frequency. So radios of the past, you had to have some way of, as the crystal drifted in them, updating that with sticking a screwdriver and adjusting a pot or some other way. This keeps the radio always on frequency. So you don't have to always have this on there, but if you do, it makes sure the radio's on frequency. We do have an option to put a GPS disciplined oscillator in the radio, which will give you also a 10 megahertz output, and it has slightly higher performance than the GNSS that comes in the radio. GNSS, by the way, just means it's a global navigation system receiver, so it receives not just the US GPS system, but also ones from other countries, which I'll show you in a minute. So this is the back of the radio, the business end. There's where the GNSS antenna goes, and that's standard. There is a port that's closed here for serial. It's for synchronous serial communications, which I'm sure none of you care about, but that's present on our military radio. There's also a 1 PPS input here, which is also only available on our military radio, so it's not used for this. There's a place here for the display connector, which is a HDMI connector. That's only available on the M series, so if you have one that has the display on the front, you can also do that on the output of it. There's a 10 megahertz output here that's only active if you have the GPS disciplined oscillator, and there's a 10 megahertz input on the radio. So if you have a 10 megahertz standard in your shack for some reason, you can run it in here instead of using the internal GNSS receiver. There's exciter and receiver ports on the back. This set is only available on the 86. The ones just to the left of it are available on the 84 as well. Any questions about the back of the radio and what's back here before I go on? Okay. All right, so the GNSS receiver is a 32-channel multi-system capable. Its time to first fix from cold startup is about 35 seconds. It's a lot shorter on warm, of course. Here's the different systems that it supports, the US, the Russian, the European, and the Japanese systems, and it also has the wide area augmentation systems as well. This is the number of channels on each one of those and what the signal is for those of you that are GPS nuts. This slide shows the wide area augmentation systems that are available in different countries, so we'll use this in addition to the GPS signal if you're using this. Any questions about GNSS receiver before I move on? Okay. All right, so talk now about the new Maestro that we have. We've done 2 versions of the Maestro before, so this is the 3rd rendition of it, and here's some of the things that we've added to this one. We added improved Wi-Fi capability, so we have MIMO antennas in it. It is now compatible with Wi-Fi 6, which came out, I think, last year. We've improved the CW side tone. It was, frankly, a little raspy in the A and B version, so it's much better. It's a nice, clear tone now. We have a rechargeable battery option in this. If you get the rechargeable battery, it runs about 8 hours on that battery. It's a 99 watt-hour battery. We do have a new power indication switch on this that matches what we have on our M series and our other radios, so all that looks identical across the radio family now. There is a pseudo-differential mic input now on this. There's an HD display output, so there's an HDMI connector on this if you want to connect a monitor to this and put a big monitor in your shack to show what's going on. We did integrate the mic and headphone connector into what's called a CTIA connector. This is the same connector that Apple uses in their, or used to use in their iPhones. So it's all on one connector. We also sell a cable to split those out if you want to do that. This unit does run on 24 volts, whereas our previous ones run on 12. We would love to have run it on 12, but to charge the battery internally, we really needed the 24 volts in order to make that work. So that's how we set it up. This is what the Maestro looks like. If you haven't seen one of these or touched one before, we've got a couple in the booth. You're welcome to stop by and play with it. Here's the battery compartment on the back and gives you a rough idea of the size of the battery. Again, it'll run about 8 to 10 hours on that battery. Along the back, there's a series of connectors. There's a push-to-talk, a CW key, a powered speaker output, a line output. There's the CTIA connector, which gives you headphones and mic, so it's a one cable to use a headset that has headphones and mic. And then there's the power input cable for 24 volts. We do have available a battery charger here that's a single watt, single bay fast battery charger. If you want to get one of those, you just plug it in the wall and drop the battery in it so you can buy multiple batteries and charge them. This is what the Maestro costs, as well as the battery, the rapid charger. There is also an option for a dual battery charger if you wanted to charge 2 batteries at once. All right, I'm going to move on and talk about Smart SDR features now that are new. So we just released version 3.8.19. It works both on the 6000 and the 8000 series. We added squelch across all voice modes. Prior, we only had it in FM. Now it works in AM and sideband and that sort of thing if you want squelch. This is an often requested feature, so it's not one that I would use, but a lot of people use it apparently. We do have TGXL and PGXL integration with Smart SDR. I'll show both of those to you. PGXL is in the software today, and I'll show you what the TGXL looks like so you can get an idea for that. We have analog meters and USB cable pass-through that are coming out as well. I'll show you the analog meters, and I can talk a little bit about the USB cable pass-through. The brief idea of that is, let's say you have a rotator that you want to control remotely. You can plug the rotator in through a RS-232 USB cable in the back of the radio, and then on the remote end where you have a computer, you can plug a cable in there or use your rotor control software on the computer, and it will tunnel through the Ethernet connection to the radio and pop out on the serial connection. So if you had a rotator control application that's expecting a COM port, you can run that on your remote PC. It tunnels through the Ethernet and controls your rotator remotely, or whatever else you happen to have that you want to control. This is a PGXL and TGXL. They are 1500 watt PA and tuner respectively, and there is a app that's a standalone app to control both these, but we've added the capability in Smart SDR now. So this shows you what the TGXL, the Tuner Genius control panel looks like. Here it is. There's an indicator down here that shows you the status of that, and I'll zoom in here and show you kind of how it works. Whoops. So across the top is the forward power, and then you've got the SWR. The forward power goes up to 2,000 watts, SWR up to 3. And then you have the 3 settings for the pi filter. So you've got the CLC settings that you can see there, and you can also drive those and click the bypass to bypass it if you want. There's a tuning indicator down here that's now next to the amp indicator, so when the tuner's active, it'll light up like this. Similar kind of panel on the Maestro. This is what it looks like on the Maestro. So there's an indicator up there. There's an SWR meter, power out meter. So you have that all available on the Maestro. The compression meter's just the ALC compression meter down below that's normal. And then there's a setup panel on the Maestro that shows up in the main menu of the Maestro. So you can go here and look at what the IP address is. Is it set up for DHCP? See the CLC settings. The status of it is in operate, bypass, standby, whatever. Yeah, so I ran through all that. Okay, any questions about that before I move on? Yeah.
Any plans to support additional tuners beyond the TGXL?
Yeah, any plans to support additional tuners? Not that I'm aware of. We hadn't talked about doing that. Now, the USB pass-through support may allow you to do that. So if there's a serial way to control your tuner, you should be able to do that and run the tuner application remotely. I don't have a way to do that on the Maestro, though, because there's no way to pull up your own panel on it today. Okay, so we're adding analog meters. These have been designed, just not integrated in the software, so we'll add them in here at some point. So these are completely digitally created faux analog meters that look like analog meters. So we can give you a number of different capabilities in it. So this shows you there's a drop down on transmit. You can select between power and SWR and show those. And here's an example of what the meter looks like. This one doesn't have the ballistics in it yet, so it's a little bit jerky. Here we go on, you can select power. You can select on the receive side, do you want the digital display to show S meter or actual dBm value received in the radio? Here we'll select to SWR, so there's the SWR display along the bottom. That would be in transmit in the top stir and receive. You can also show the mic level, and then there's also a compression level if you want to show it that way. All right, let's see what else here. So this is what it looks like on the Maestro. So a similar rendition on the Maestro. You can pull it up on the meter panel. And there it is moving. So there's the meter. You can turn that on and off by tapping on the analog button down there in the bottom. There's your normal add different meters. Click on them to remove them. And then you can just tap on the display to change what it's showing. All right, so I want to talk a little bit now about the roadmap for the 8000 and some of the features that we're going to be adding to that over time. So since we have all these extra capabilities that we're going to add, we'll add these over the course of 2025. Some of those features are going to be hardware dependent that are simply not possible on the 6000. Some of them will not be possible because there's just not enough horsepower in the 6000. So all the things I'm about to show you are going to be available in the 8000, but some of them may or may not be available in the 6000, just depending on what all goes on. So how many of you are familiar with transmit intermodulation distortion, or IMD? So a few of you. So I want to talk a little bit about what this is and what we're doing about it. So IMD is caused by nonlinearities in a linear amplifier. So anytime you have a linear amplifier, it has some nonlinearity in it. And that's either an external amplifier, like if you had a 1500 watt amplifier, or even the 100 watt amplifier in your radio. So what happens is there are products that are generated that have relationships to the signal that's being passed through the amplifier. So this is a typical test for IMD. You'll see QST runs these tests in their reviews. This is called a two-tone test, where we transmit two tones that are close to each other out of the radio. And when we do that with those fundamentals, these other tones show up. And this would be the third order, the fifth order, the seventh order, and so on, IMD coming out of the radio. And this is a very normal thing. Any amplifier is going to have this happening. So it's not a FlexRadio thing. It happens in all your amplifiers. This is an example from the cellular industry on what it looks like if you're transmitting a multi-carrier cellular signal. So the input here is the blue signal, and the output is the red signal. And this hump that you see that's above the blue is unwanted RF that's coming out of the radio. In the cellular industry, they call this spectral regrowth, but it's intermodulation distortion from all the carriers that are present in this kind of Bart's head signal that we're transmitting. And ideally, what we want is the signal in to look like the signal out. So why do you care? Well, it's neighborly not to splatter on the band. So if you've ever worked a contest and there's somebody that's turned it up to 11 in their amplifier and they're splattering, you know how uncomfortable that can be to operate next to them, hearing all that junk come out. There's actually Part 97307 in the emission standards that says to the greatest extent possible, you need to eliminate this kind of stuff. So there's actually a rule, trying to get us to do this as well. And frankly, tube amplifiers were better about this than our transistor amplifiers today. So in the amateur world, we've kind of gone backwards a little bit. So let me talk a little bit about what this looks like. I'm going to take a theoretical 10 dB gain amp here and show you what this looks like on a graph. So along the x-axis, I have power input. So at the point where everything conjoins here in the bottom, that's 0 power input, and on the right side would be my, let's say, 10 watts input. And then my output is on the vertical axis. At the bottom, it's 0 watts out, and at the top, let's say it's 100 watts out, because we got 10 dB gain here. So if I put in 1 watt, I get out 10 watts. If I put in 4 watts, I get out 40. If I put in 10 watts, I get out 100. Now, it may look to you like I'm creating the Cessna logo, but that's not really what I'm trying to do here. What actually happens in this is the yellow line here. So you can see the blue line is the idealized line. The yellow line is what actually happens. So you can see it droop a little bit off of ideal, both on the low end and the high end of the spectrum. So what actually happens when I put 10 watts in, instead of getting out 100, I get out 95. Well, it doesn't seem like such a big deal, but what happens is this is what's called compression. And if you go look at the data sheet for any transistor that you might build a power amplifier out of, they're going to spec this. They'll call it P1 dB or P3 dB. P1 dB is the point at which when you put in power, let's say in the middle of the power curve, the difference between that and the high end where you're having this compression occur, the signal is 1 dB less than it should be according to the actual gain that you should be getting out. P3 is 3 dB down. Now, we don't ever transmit in the P3 dB range, but we do end up in P1 dB sometimes. So how do you fix this? Well, there's multiple ways. One way is to run what's called Class A. In Class A, you reduce everything to where the range of the amplifier, you bias it way up, and you get a transistor that's oversized for what you want to do. The issue with that is it costs a lot more power, and it costs a lot more money to build with the extra transistors. And some of the manufacturers have done this. I think it was Yaesu a few years back created a full Class A radio. But there is another way to handle this, and if we knew how the signal was going to be distorted, if we characterized it, if we calculated what the input power level would be to actually produce the correct power out, then we can change the signal as it goes in. So we could look at every voltage sample going into the amplifier and say, is this one going to be distorted by the amplifier? If so, we can adjust it some upward or whatever in order to get the correct signal out. And that's what's called pre-distortion, because we're distorting the signal before it's actually distorted in the transistor. Now, there's multiple ways even of doing pre-distortion. There's two main categories. There's static and adaptive. In static pre-distortion, what we do is we do one calibration on the amplifier. We figure out a rough solution, and then we implement that. And we typically see somewhere in the range of 8 to 10, maybe 15 dB of benefit out of that. So those extra tones, the products that I showed you on where we had next to the fundamentals that are undesired, those would go down by 8, 10, maybe 15 dB. In adaptive pre-distortion, we examine the spectrum in real time and watch what the transistor is doing, because this will change according to your antenna, the temperature of the transistors, the power output, various things. And then in real time, we adjust that. And we typically see 10 to 25 dB of benefit doing that. So what we're implementing in the Flex 8000 is adaptive pre-distortion, the better kind, if you will. And so this dynamically characterizes the PA performance, builds that correction model, and then applies that correction model in real time. So we have this working in the lab. I'll show you a couple of slides that show you what it looks like and what it does. And we're going to release this probably, my guess is December of this year, January next year, somewhere in that time frame. This will be available on all the 8000 radios. They have what we call the sampler that looks at the output signal and feeds it back into the receiver so we can characterize it. And that's in all the hardware. One question is, will it be available in the Flex 6000? So we're investigating that. I think it's likely that we will be able to do it in the 6000. If we do, it may require some external hardware and stuff like that. So we don't know exactly what that's going to look like yet, but as soon as we get it working on the 8000, we'll roll back and look at putting it in the 6000 and whether or not we can make it work and all that kind of stuff. So there's several things here. So it works with the 8000 100-watt power amplifier internal to the radio. So it's completely self-contained if you want to use it. But it also works with an external PA using a sampler, which we'll make available. So this assumes that the will have a sampler that assumes that the power that you're trying to use is less than 2 kilowatts. The sampler will be tuned for that. So if you're trying to use a 5 kilowatt amplifier on your ham radio, we're not going to support that. We do have a sampler already built into the PGXL, so you'll just run a cable over for the PGXL if you want to do pre-distortion with it. So here's kind of the three use cases, if you will, for pre-distortion. On the left, we have standalone. You just hook an antenna to the radio and operate, and it'll work. If you have a PGXL, you're going to run a cable from the PGXL sampler over to the radio, and so we'll have you should run a cable over to do that, and we'll have a how-to guide on how to do that. If you have a third-party amplifier, then you'll need to buy a sampler from us, which we'll make available. You'll stick the sampler after the amplifier. A cable will come back from that over to the radio. The sampler that we're building also has the capability of supporting an extra receive antenna. So what will happen is you'll run the sampler over to like your RXA input port or your RXB input port, which will tie up that port. So the sampler is going to have a way to plug an antenna into it, so when it's not being used for pre-distortion, the antenna will pass through the sampler and go to the radio so you don't lose the port. Okay, so this is a snapshot on a spectrum analyzer. I hope you all can see that, but in the lower right corner, which is probably impossible to see, it shows what the products look like. So this is a before shot, and the two products are minus 33 and I think minus 38 or something. That's the marked as on the left, the third order product, 2 plus 1 and then 4 plus 3. That's how far down they are. When we turn pre-distortion on, this is what happens. They go down to minus 41. So we get a significant advantage. And so this is just an example. The amount of benefit that you're going to get is going to vary by band and all kinds of other stuff. And I don't have a complete set of slides to show you what it's going to look like for each band and all that. This is just an early run that shows you kind of what it's going to do. Any questions about pre-distortion before I move on? None? I can't be that clear. It's not possible. Okay. Yes?
If you have an older radio or whatever, does this goes in between the radio and the antenna tuner?
So you would put this, so if you're using a Flex 8000 standalone by itself, then everything's inside the radio and you don't do anything. You can put an antenna tuner on the outside of the radio if you want to do that. The radio has an antenna tuner in it as well, so you don't have to do anything. If you have a third-party amplifier, then this would go after the amplifier because you want to close the loop with the amplifier inside the pre-distortion. Does that answer your question?
I think so, because I have a IntelliTuner MFJ 200 watt tuner.
Yep.
And then this would go above that or whatever.
You want the tuner outside the loop.
Tuner outside the loop.
Yeah,
okay.
yeah.
So this would go before that.
Yes.
Before
You'd
that.
put the sampler before the tuner, then you'd have the tuner, then the antenna.
Okay.
Yeah.
It works well inside environments or whatever? Or?
So the pre-distortion is designed to be working with the radio and the amplifier, which are all going to be indoors. So, yeah, by the time the signal exits your shack, it's all good.
Okay.
Yeah.
How much improvement do you see on the higher order distortion products?
They go down a similar amount, I think, from what I've seen. Again, we just really have this working in the radio in the lab. We've done a lot of pre-work to make this work, but it's going to be another probably 3-4 weeks before I really have good numbers on it. So I really can't tell you a lot today. I can just kind of show you that we have it working and we know that it's working, but we still have a lot of tuning to do on it. One of the things that has to happen in order for this to work is that we have to do essentially a sample collection of data before we create. So pre-distortion works with two pieces. It has a sampler piece that creates an equalizer, and then the equalizer goes right before the PA. And so we have all of those pieces working, but in order to really characterize the whole radio, you have to run the sampler with a bunch of inputs across all the different bands on different antennas and different kinds of things to find out how it behaves in different scenarios. So that's all the stuff we're going through right now. So we have the basic thing working, but we got to go figure out, what we're going to get out of it. Do we need to tune anything for different kinds of scenarios or any of that? Does that help at all? A little? Yeah.
Okay, so, if I'm running only 100 watts, what are situations where I would,
Just so we're clear, this will not benefit anybody in this room. So this feature is designed to benefit your neighbor, right? Yeah, so your neighbor will see these products go down. So let's say that you're, you got a contester that's down the block from you or something. All these products will go down and he won't see them. So on one hand, you can argue that, because these products are already 30 dB down, the signal has to be 30 dB out of the noise for your neighbor to even see it, right? Because at that point, the products will start to come out. But if you've got a guy that's, S9 plus 10 on your pan adapter, then all those, signals are going to be there. He's going to, if he's talking on voice, he's going to look real wide. He's going to look like he's outside of the 3 kilohertz bandwidth he's supposed to be inside of. He's technically not, because those are all down below a certain level. So it's going to clean those up, and those will all go down some. I have another picture, which I don't have, I don't think, in this slide deck that shows you, but you can see a guy see a signal that we're transmitting that has multi-carriers in it, and there's like this fringe, stuff that on the side that looks like what I showed you with the cellular guys, and all that just goes away, and now he's occupying just his bandwidth for the most part. I mean, the stuff's further down, so it just cleans up the bands. And how many of y'all have heard of the ARL CSI, Clean Signal Initiative? So the Clean Signal Initiative, the level at which these products are specified in that, for everything but a Class A radio will require pre-distortion. So if you want your radio to get the seal of approval from the CSI, it's going to have this feature in here. So this is just a way to clean up the ham band some and make it so more people can occupy the band. Anything else? All right, well, this is one of the other things I want to talk about that we're going to add to the radio. So the most popular mode today is FT8, and so this red line here demonstrates that. The other colored lines are the other modes. How many people in here use FT8? How many people hate FT8? Yeah, so there's some of that. Okay, all right. So one of the problems with FT8, and you guys that hate FT8 are not going to like this part of the talk. I'm real sorry for that. But everyone is scrunched into 3 kilohertz of bandwidth. So, this is what the bands look like when they're not open. But you see all these guys on FT8 that are confined to this 3 kilohertz. So one of the things that we're going to do is, in this radio, is enable amateur wideband. So we've already done this in the lab, but this will allow you to transmit and receive over 40 kilohertz of bandwidth. So you'll be able to take your radio and point it at 40 kilohertz of bandwidth and say, I want to decode all the FT8 signals in there and work any of those guys. And so this will allow you to do that. You'll also be able to transmit multiple carriers at the same time. Now, it will reduce your power when you're doing this. So anybody in here run 1,500 watts on FT8? Yeah, nobody's going to admit that, right? Okay, all right. So anyway, this will allow you could take a 1,500 watt amplifier and do this. Each carrier, if you're running like 8 carriers, might only be 100 watts or something, but it'll allow you to do some things like that. So you can work multiple people at the same time. So let's see, multiple transmit channels, yes. The radio will ensure compliance with the rules, so you won't be able to transmit a 40 kilohertz wide signal. If you were thinking about doing that, the radio won't let you do that. It will let you transmit multiple 3 kilohertz signals at the same time. And we're going to be working with open source code vendors to make sure all this stuff makes it into open source code, so if other radio vendors want to follow suit, they can do that. So this is what we'll do, is we'll increase the space that you can use FT8 into a further area, up or down or whatever else. One of the things that we also want to do with this, most people aren't aware, but the way that we and other vendors do digital modes is that we take either Ethernet or USB and we make that available in a device driver under Windows or Mac or something like that. In our case, the source data that moves over the Ethernet is a national standard called VDA49. We turn that into a sound card, and then your FT8 application runs against that. So you have to fool with these Windows sound cards and all that kind of stuff. One of the things that we're going to do as part of this is that we're going to bypass all that stuff and go directly to the Ethernet data streaming, which allows us to use wider bandwidths because the sound cards aren't geared up for 40 kilohertz. The other nice thing about this is most people don't realize it, but you're limited to 96 dB of dynamic range in a Windows sound card, and this will expand that range because our radio has significantly more dynamic range than that anyway. So if you know somebody who likes to code in open source applications and might like to work on something like this, feel free to send me a note because we'll be paying some people to do open source work in this area. All right, next feature I want to talk about is spectrum overview. I don't have a lot of detail on this, but we want to provide a single view of the spectrum that gives you all the bands that you want to look at. So let's say that you want to operate on 20 meters, but you want to keep your eye on 10 and 6 in case they open up, like today. What you could do is you'll create a profile for that, and you'll say, I want to watch 20, 10, and 6, and you'll have a single pan adapter at the top of your display window that shows all three of those bands in high resolution. We have a new capability to add extra resolution in the 8000, so you'll be able to see the activity on all those bands and then go switch to one of them if you want to do that. So it allows you to keep an eye on the bands. What else here? Yeah. We have some advanced noise reduction stuff that we're working on that we'll put in the 8000. I won't spend a lot of time talking about that. We have an integrated NTP server. I kind of think this is actually in 3.8. I haven't checked yet, but it uses the internal GNSS as a time standard. So if you're using WSJT, and let's say you're in the boondocks running off a battery, and you want to know the current time to synchronize WSJT, instead of trying to use your cellular phone and point it at some sort of time standard on the internet, you just point it at your radio, and your radio will be a time standard. Any questions about any of that before I move on?
6 is open right now?
10's open, I'm sorry. I don't know if 6 is open. 10's open, though. Have you seen 10? Man. All right, we already talked about that. So the 8000s, we're shipping now. We've just started shipping as of last week. So the customers that put down a deposit in this May 24 are currently getting their radios. If you ordered one today at the show, it would probably be somewhere, I'd say, mid to late January before we ship, because it's going to take about that long to get through our backlog, so just so everybody's aware. If you have ordered an 8000, it's very beneficial to us if you don't call us and ask where you are. We're going to try and find a way to give people a better idea about when their radio is going to come out, but there's so many people on the list that it's a lot of emails to answer, and it would help us a lot if we didn't have to answer all those. I understand everybody's impatient, and we're doing everything we can to get them out. If you don't have one and you want to purchase one, you can send a note to Andy at FlexRadio or sales at FlexRadio, and we'll get back to you and set all that up. There's a $500 deposit. We don't charge you the full amount until we ship the radio. That's it. I made it through 74 slides in 48 minutes. We have 10 minutes. All right. Okay, thank you all.